Okay, let's start by creating a new C++ project, and I'm just going to create a blank project. Okay, so we have the project up and running, and it's just a blank project. So in the root directory of the project, I'm going to copy and paste this plugins folder. And this folder just has the cover generator plugin that I'm going to showcase in this video. So let's close the project and reopen it. Okay, so we are back in the project now, and in the plugins folder, if you go into the maps folder, you'll see that the plugin comes with a map that has some random static meshes, and there's a copy of the cover generator plugin, and it has some settings that you can tweak. So what it does is that at runtime it analyzes all the level geometry and produces or generates some cover points around them and exposes these points to the EQS system. So if the draw debug checkmark is ticked, and if I simulate, you can see that it's generating these points. And this should be pretty optimized for large levels. So now let's get to building our tactical behavior using our state tree. So for that, I'm just going to go into the content folder and let's import the third person template so that I have some animations. Let's go into the third person blueprint. Okay, so the first thing that we need to do is to implement an interface. So let's add the cover target provider interface. Okay, as soon as you do that, you'll see that under interfaces, you'll have this function that is asking for an actor. So we can promote this to a variable, and let's rename this to target, and let's expose this. Okay, so now let's place one of these into the level. Okay, so in the details panel, you'll see target. Let's select the other one as the target. Okay, now next we need to create an AI controller. So AI controller, AI controller base, and in here what I'm going to do is I'm going to get the cover target, get the pawn, get control pawn, and from that I'll call the interface function get cover target, and if this is valid, we'll check if this is valid. Then we'll do some other stuff, but before that we need to enable a plugin. Let's see, gameplay or was it gameplay state tree? Let's restart. Now let's create a folder and let's call it state tree. I'll create a state tree and I'll select state tree AI component. Okay, back in the AI controller, let's add the state tree component, state tree AI component, and let's assign it. But I don't want the logic to start automatically. I'll start it if the target is valid. But the cover generation takes a few frames, so I'll delay it for a few seconds. So let's add a delay of 2 seconds. And then I'll start the logic. Start logic. Okay, and in the character itself, let's make sure that the AI controller is assigned. AI controller base. Okay, so let's set these. So for the AI controller, it would be the AI controller base, and for the context actor, it would be the third person character. Let's compile and save. And in the parameters, let's create a vector parameter. Let's rename this to, let's say, cover point. Okay, so this state tree would be a very simple one. It would have just 2 substates. So find, cover, and wait. So under wait, we will have just one task, which would be task delay. Let's say for 5 seconds and a random deviation of 1 second. In the find cover, we will have 2 tasks. So let's set this to all instead of any, so that both the tasks complete. So we can run an EQS query, and the query would be this cover query, and it comes with the plugin. Okay, so let's take a look at this query. It has this custom EQS generator that pulls the points that are being generated by this cover generator actor. So these points, and by the way, these points are being generated at runtime. So if I change the location of the meshes, you can see the points update, and the freeze that you saw, it happens only once after you start the editor. This is a conflict with the world partition system, but after the first time it doesn't happen. As you can see, I'm moving the meshes and everything is updating smoothly. So the generation is async, it is spread over a few frames, and all these calculations are happening at runtime. Okay, so let's move back to our state tree, and it is asking for a result. So we'll provide it the cover point parameter that we created. Then after that, the find cover state will have another action, which would be to move to the cover point, and we'll pass it the same cover point. We'll allow strafing, and let's untick these two. Okay, so the transitions are missing. So from find cover we need to move to weight, and from weight we need to move to the root. Still okay. Okay, so I was in play mode, so I did not update. If we simulate, we'll see that the character will wait for a few seconds and then move to the cover point. But there is a problem. If there were more than one characters, they would all select the same point and try to move to it, which looks stupid. So what we need to do is, instead of running this EQS query, we need to write a new task. So let's do that. I'll delete this and I'll write a new task. Let's say find cover. On enter state, I will run the EQS query. And I'll select all matching. The query would be the character. This will be of type third person character, and I'll put this in the category of context. This will be the query. Let's select the cover query. I will then assign on query finished. Let's name this select cover point. Okay, I'll get all the points, get results as locations, and from here I will try to reserve I'll get the cover subsystem, cover reservation subsystem, and I'll try to reserve from query results. So this will reserve the cover point, and that this will reserve the cover point that this bot is trying to reach, and that would make it so that the other bots cannot select this point. If we look in the cover query, there is a test that reads cover available. So if this cover point is already reserved by another bot, this will return 0. So now we can set this as the cover point. And the way to do this is to create a variable of type, let's see, this state tree property reference, and let's expose this destination. Okay, now after we compile this, we can set the type, and this will be a vector. Okay, so now we'll get the property by reference, get property reference, and then we'll set by reference. This will be the target, and this will be the value, and then we can finish task. Okay, back in our state tree, we need to assign this. So state tree, but this needs to be the first. Okay, in the destination, we'll bind this to the cover point, and the actor is the actor, the AI controller is the AI controller. Okay, so this should be it. Let's see. Something went wrong. Did we select the query? We did. Okay, we did not pass the requester, so the character will be the requester. Save, and actually let's increase the delay to 5 seconds.